Hello everyone, and welcome to my channel. This channel is for educational purposes. We take a look at theories of everything that you probably haven't heard of before, and we take deep dives into them and hopefully show you how you can incorporate these things into your life for positive change, helping you with your own paradigm shift and your great awakening, your shift into 5D, or however you want to think about it. And today is our 425th video on the reciprocal system of theory from one Dewey B. Larson. And Mr. Larson, in about 1959, proposed his two fundamental postulates about how the universe operated. He eventually called it his it is called the reciprocal system of theory, but he also calls it the universe of motion. And he constructs his universe not on matter and not on energy, but on motion. His first postulate states that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. So those are really the 4 prongs there. Universe of motion, special kind of motion that we will talk about. So 4 prongs, universe of motion. Motion exists in 3 dimensions. It exists in discrete units, and it has 2 reciprocal aspects, space and time. So Larson is talking about not motion maybe the way you think of it, but he calls it a scalar motion. This is a motion that has a magnitude, but it has no specific direction. And you can envision this using a balloon that you put dots on. If you blow up the balloon, all the dots will be moving away from each other, but not in any specific direction. Each dot will be moving away from each other dot. Every dot will be moving in every direction. And that is called a scalar motion. And that motion has been acknowledged by scientists, but not really investigated. Hubble and his associates way back about almost 100 years ago observed that the distant galaxies were all moving away from each other. This they used to come up with the idea of the Big Bang, but it could just as easily be used to come up with the idea of the expanding balloon. That there isn't a center point of this. Not until you actually decide that one of the galaxies is at the center and is the reference point and is motionless. But in scalar motion, all of the galaxies, or in this case dots on the balloon, are moving. And so we've got this scalar motion. And motion is the relationship between space and time. Motion is basically a fraction with space or time as the numerator and time or space as the denominator. Such as speed. Speed is space over time. The car is moving 15 miles per hour. 15 miles of space and 1 hour of time. But the inverse quantity would be energy. Energy is measured in time over space. It took me 3 hours to push that thing 1 mile. 3 hours of time, 1 mile of space. And but then you also have to keep in mind that the motion comes in 3 dimensions. And so space and time also come in 3 dimensions. We see that in space as what you call coordinate space, or really Euclidean geometry, XYZ coordinates or volume in a still frame. Now that is really an abstraction. You have to really stop the universe to get to this. You have to stop at least the space part of the universe while time keeps progressing in a scalar manner. So in our sector of the universe, we see 3 dimensions of space in a still frame, and we see time progressing or flowing. If we were in what Larson calls the cosmic sector, we would see space as flowing or progressing, always getting farther and farther apart. And we would see time as 3-dimensional in a still frame, with possibly maybe something like polar geometry. And just also, before we move into the discrete unit postulate, keep in mind that, in order to really accept Larson's universe of motion, there's a few things that you have to obstacles that you have to kind of get over. First is that you have to be able to conceive of a universe that has motion without anything moving. The motion exists before the thing that's moving. Motion is primary in a universe of motion. So you can have an empty universe with motion in it. Larson calls that the progression of the natural reference system, the outward movement of the balloon. This is always present, omnipresent, and eternal. It's always occurring. And this is the state of the universe of motion. Also, in a universe of motion, where space and time are the two components of motion, you no longer have like the setting idea of space and time, where we are going through our paces in a setting of, 3-dimensional space and progressing time. That this is the stage upon which we act. In Larson's universe of motion, in his reciprocal universe, space and time are not the container of the universe, rather they are the contents of the universe. The universe is made out of space and time. As, matter is also a form of motion. So we are made out of motion too. Matter in Larson's time-space, coordinate assignment is time to the 3rd power over space to the 3rd power. Okay, so now we are looking at a book that Larson wrote. It's the 2nd volume of his 3-volume series, the 2nd edition of it, that is called The Structure of the Physical Universe. The 2nd volume here is called Basic Properties of Matter. In this book, what Larson does is he takes his 2 fundamental postulates. We went over the first one. The second one is just kind of more axiomatic. The universe is, it conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. There's some dispute about several prongs of that 2nd postulate, but that's kind of a more advanced level here. So we'll just ignore that for right now. And but basically the idea is that Larson took his postulates and put them through a process of deduction, of kind of an if this, then that approach, and built up what he calls a theoretical universe, what his universe would look like if his postulates were correct. And then in his books, including this book here, Basic Properties of Matter, he compares his theoretical universe with the observed universe of the chemists or whatever science, he's astronomers or whoever, and that they measured in their laboratories, and they compiled in their scientific tables, and Larson arrives at equations for the basic properties of matter, such as the interatomic distance, the compressibility, the specific heat, the melting point, things like that, and makes a comparison. It's amazing. Maybe Larson cheated. That's a possibility. Fraud is always a possibility. But if he is, kind of telling the truth here, he's really able to practically reproduce the scientific tables strictly from theory out of his own head without $1 million devices and $1 billion grants and a whole army of scientists dedicated to the task. By himself, he is able to reproduce the vast majority of these scientific tables, within 1% of their values. So we're gonna take a look at we are in chapter 3 of this book called Distances and Compounds. Now let's get back and look at this discrete unit postulate a little bit more, because it's more relevant here for this chapter or for this book. Now, Larson says that the universe is composed of matter, of motion, and motion exists in 3 dimensions in discrete units. Space and time also exist only in discrete units. You have to have a full unit of space before you have space. You have to have a full unit of time before you have time. If you have 1 unit of space in 1 unit of time, space over time being speed, you have what Larson calls unit speed, which is also known as the speed of light. So the speed of light is really like the background speed of the universe. This is the speed that goes on in the empty universe when you have nothing else. This is the ubiquitous, eternal speed, background speed of the universe. He calls it the progression of the natural reference system, or the null point, or the neutral point, or the 0 point. You could call it the origin or the ether. These are all the background speed of the universe, and the construction of the universe occurs by, kind of harnessing this outward speed and kind of like moving it to being inward speed is how you change this motion into energy, and then momentum, and then matter, and so on. And what this also means is that the progression of the natural reference system is the midpoint of the universe, meaning that half of the universe is actually moving faster than the speed of light, which is blasphemy to the scientists. But Larson calls this the cosmic sector. And then half the universe is moving slower than the speed of light, the material sector that we're familiar with. And again, these are reciprocals. The material sector is based on 3 dimensions of space in a still frame progressing through time. And but when you cross that unit speed boundary, then the roles of space and time reverse, and you have 3 dimensions of time in a still frame, and you have space progressing in a scalar manner, the flow of space or the progression of space. And this also creates separate subunits within the material sector and the cosmic sector. In the material sector, you have interactions that occur in less than 1 unit of space. If you have something, you cannot have less than 1 unit of space. because of the discrete unit postulate. You have to have a full unit before you have a unit. So these interactions actually occur in time, not in space, because it's got to be one or the other, because space or time are the components of the universe. So it has to be one or the other or both. So if you don't have space, you have to have time. The unit of time is 4.56 times 10 to the minus 8 meters. So you are dealing with microscopic phenomena of interactions of atoms, particles, molecules. And so this is kind of what he's talking about here. So these are occurring within what he calls the time region. And so too, in the cosmic sector, he has what you call the space region, which is where interactions that occur in less than 1 unit of time actually occur in space, because there is no time less than 1 unit. And so these are, the realm of interactions of cosmic atoms, cosmic particles, and cosmic molecules, which legacy scientists call mesons and antimatter. Okay, now Larson is able to basically theoretically determine that this interatomic distance is occurring at the point where the progression and the gravitation are at equilibrium. Now, it's important to note that if you move across that unit space boundary, the rules again invert. And instead of having an outward progression and inward gravitation, like gravitation being analogous to sucking the balloon in and all the dots moving toward each other, but in the time region, those roles are reversed. So the progression is now moving inward and towards zero space, and the gravitation is moving outward toward a unit of space. And there is some point there where they are at equilibrium. Even though the progression is constant, gravitation is variable based on an inverse square law. And so there is a point where gravitation and the progression are equal, and that is the point of the interatomic distance. Now, as we learned yesterday, this interatomic distance is not the size of atoms, as the scientists claim. It is the distance that they are apart. So Larson comes up with various expressions for this, depending on the orientation of the atom or molecule. In this chapter, we're dealing with molecules. Now, it's also important to figure out, what's the structure of the atom. So the atom starts with 2 photons at its center. Photons are simple harmonic motions or wave-like motions. Now, there's a dispute between Larson and some of his followers about how that comes about. We'll bypass that for now. We'll just say they're simple harmonic motions, and there's 2 of them kind of oscillating around the same point. And those are progressing out at the speed of light, as if they're on the surface of an expanding balloon, until they get slowed down. But they have to get slowed down in 3 dimensions, because space, time, and motion come in 3 dimensions. So you have each atom in Larson's system has a 3-number set called, the same as the periodic table number. Like, so oxygen is 8 in the legacy science system. In Larson's system, it is a 3-number set, 2, 2, -2. That's 2 primary 2-dimensional rotations. That's how you turn back this progression of these 2 photons. First, a 2-dimensional rotation, and then there are 2 secondary 2-dimensional rotations that these two-dimensional rotations alternate, first one and then another. So you have two of each. And then you also have -2 one-dimensional electric rotations, or he calls them electric, he calls them two-dimensional magnetic. And that is in moving in a scalarly opposite direction, meaning as a in or out. The only scalar direction there is in or out. Okay, so that is really, those are the numbers that Larson is kind of manipulating to get his various equations here. Okay, we'll start here, and hopefully we can kind of figure out where he's going. Again, this is like detective work, so you're going to just have to piece it together. It's not going to be on a silver platter for you, which you probably have figured out already. Okay, in these compounds of the magnetic type, now he's also talking about magnetic, so in Larson's system, he's kind of being honest where the scientists are not. The scientists always talk about the electric universe and that bonding is occurring on ionic bonds, such as the NaCl bond, where you have a valence of +1 on one side and a valence of -1 on the other side, and they attract electrically, and that's what causes the bonding. But the scientists don't really tell you that the vast majority of bonds are not ionic, and they have little or nothing to do with this electrical type of bonding, and especially in the metals. And Larson uses other kinds of valence, that the magnetic groups, the two-dimensional rotations, can also bond based on a maximum number of 4. So you can have magnetic bonding as well as this electrical bonding. So that's, I believe, what he's going to get into here. In these compounds of the magnetic type, the displacement of the negative component -x is balanced by a numerically equal positive displacement x. Thus, the magnetic orientation is somewhat similar to the normal or electrical orientation. However, the magnetic rotation is opposite in vectorial direction to the electric rotation. And the resultant relative, that word vectorial in there is something that's confusing me, but we'll keep going. However, the magnetic rotation is opposite in vectorial direction to the electric rotation, and the resultant relative rotation effective in the dimension of combination is therefore one of the neutral values, 10, 5, or a combination of these two, rather than the 2x of the normal orientation. Compounds based on the magnetic orientation occur in a variety of crystal forms, the nature of which depends on the degree of force symmetry and the number of atoms of each kind in the equilibrium system. In some cases, there is enough symmetry to make isometric structures of the NaCl or the Ca calcium fluoride and similar types possible. Other crystals are asymmetric. A common arrangement for the binary compounds is nickel arsenide, the nickel arsenide structure, a hexagonal crystal in which the positive atoms occupy the face positions and the negative atoms are in the central positions, spaced alternately 1/4 and 3/4 along the C-axis. Table 10 shows the interatomic distances calculated for some nickel arsenide and sodium chloride type crystals of binary magnetic orientation compounds of group 3A. Group 3A is just the level on the periodic table, so the third level, I guess, or I guess it maybe even is the fifth level because it's 3A. Almost all of the nickel arsenide type of compounds that have been examined in the course of this present work take the vibration 1 value of the specific electric rotation, 10. The magnetic orientation compounds with the NaCl structure are quite evenly divided between the 10 rotation and the combination 5-10 in the 3A group, but utilize a 5-10 rotation almost exclusively in the higher groups. In order to show as wide a variety of the features of these magnetic type compounds as is possible in the limited amount of space that can be allotted to them, Table 10 has been restricted to Group 3A compounds, and the following Table 11 gives the data for a representative sample of the compounds of rare earth elements from Group 4A, together with a selection of compounds from Group 4B. So these are way down at the bottom of the periodic table, in which the identical values of the interatomic distance in the combinations of the elements of this group with the division 4 elements of Group 2A are emphasized. Okay, now Larson is, really talking about kind of the fine structure of his theory. It's not crucial that you get this, but I want to read it just in case you might glean something from it, or I might glean something from it to understand it a little bit better. I picked up a couple little nuggets there, but, I still don't quite understand what he's getting at with all of this. You have to really slow it down and read it over and over again to really get it. And as he mentioned, he only has a certain amount of space that he's allotted to this because he's one guy and he's trying to study every subject. So what he really needs to do, which he doesn't have time to do, well, he's been dead for 34 years, but is that he would need to write like an entire book on this one chapter. So that's really how his topic is going to be adequately covered, is if he was able to write a whole book on each one of his 28 chapters of this book, because each one of them deserves that much space. But he's trying to kind of cram all the information into just one chapter, and it makes it, difficult to access. Now, obviously, it's very difficult to read 28 books, too. But, another idea would be to put these things into a textbook so everything is just, dripping off of the page. The important points are highlighted and graphed out and, fancy colors and, his work just needs to be reorganized. But you can't really criticize him for this because he's one guy doing a gargantuan task. Thus far, the calculation of equilibrium distances has been carried out by crystal types as a matter of convenience in identifying the effect of various atomic characteristics on the crystal form and dimensions. It is apparent from the points brought out in the discussion, however, that identification of the crystal type is not always essential for the determination of the interatomic distance. For example, let us consider the series of compounds sodium bromide, disodium selenide, and trisodium arsenide. And from the relations that have been established in the preceding pages, we may conclude that these division 1 compounds are formed on the basis of the normal orientation. We therefore apply the known value of the relative specific electric rotation of a normal orientation sodium compound 4 and the known values of the normal specific magnetic rotations of sodium and the group 3B elements, 3, 3.5, and 4, 4, respectively, to equation 110, from which we ascertain that the most probable interatomic distance in all three compounds is 2.95 angstroms, irrespective of the crystal structure. Measured values are 2.97, 2.95, and 2.94, respectively. Okay, we'll just look a little bit at his table here. We got the type of nickel arsenide structure, hexagonal class, group 3A. We got vanadium sulfide, calculated 2.42, observed 2.42. Vanadium selenide, calculated 2.56, observed 2.55. Again, this is in angstroms. Chromium sulfide, 2.42 is calculated, 2.44 is observed. Chromium selenide, 2.56 calculated, observed 2.54. And so on. He's got another few dozen of these different measurements here. They're all, within 2% of the value. Almost all of them are within 1% of the value. And so whatever he's doing is getting the right answers. Now we just have to kind of figure out what he's doing. Now, the one thing that I did kind of glean out of this is, where he's referring to, when he's referring to orientation, he's talking about, is your atom oriented based on electrical valence, and there can be a number of different orientations within that. Basically, you're trying to the valences need to add up to zero. It basically is the way I understand it, and the zero in the magnetic dimensions is going to basically add up to 4, but it's going to add up to 5 because there's an extra unit there for the progression of the natural reference system. Or it could add up to 10, which leaves 2 extra units for the progression of the natural reference system. Not quite sure about that. And then in the electric rotations, you have values of, I believe they are 10 and 18. So still trying to kind of figure that out. We're just piecing it together, and hopefully, we'll be able to grasp this. We'll talk more tomorrow and try to progress a little bit further here. Thanks for tuning in.